In our documentary, we are analysing sustainability on the University of Leeds campus and detailing changes we think should be made to help the university meet its target of reducing carbon emissions 35% by 2020. More specifically, tackling energy usage and how energy is wasted due to lighting and heating systems being left on in empty rooms on campus. So why is it important to reduce carbon emissions and promote sustainability? In short, it ultimately boils down to three components: oil, carbon emissions, and an expanding global demand. In 2015, fossil fuels accounted for 80.1% of the world's primary energy supply, with oil contributing a massive 36.1% of this. Using fossil fuels releases carbon emissions into the atmosphere, hastening the effects of global warming whilst continuing to decrease our supply of fossil fuels. In addition to this, the US Census Bureau projected by 2050 the world's population will surpass 9 billion, creating a vastly higher demand for energy. So not only are we using our supply and irrevocably damaging the environment, but also increasing the demand and struggle for future generations. The best thing the average person can do to fight this is to simply reduce the amount of energy that you use. In the USA, providing heating, cooling, lighting and water heating in residential and commercial houses accounts for 39% of the primary energy demand. So clearly one of the major wastes of energy comes from an inefficient use of these systems in our houses or places of work. In the context of university, when lighting, heating and aircon systems are left on in the lecture theatres or seminar rooms, this must account for a drastic amount of energy wasted on campus. We collected data from a range of buildings and examined our data to determine methods to help tackle the energy issue. We used a quantitative method to carry out research operations. The data was collected through visual and written observation, photo and video documentation. The project also involved afternoon audits in buildings on campus to see where the light and temperature systems were being left on in empty rooms. The main focus was empty teaching rooms and communal spaces. The exercise was from the 2nd to 6th of March and 8 buildings were audited, making sure that audits the same buildings each day. To gain a campus-wide representation and to help our analysation of the problem, we examined a variety of building types across the campus, incorporating old, new and refurbished buildings. These were Michael Sadler, Baines Wing, Parkinson Court, Roger Stevens, Laidlaw Library, Civil Engineering, Electrical Engineering and Maurice Keyworth. We walked around each building in pairs looking for empty teaching and communal areas that had the light and heating systems left on. Then we documented our findings and took some camera footage. The method used is appropriate and effective when thinking about the overall aims and objectives of the project. The audit gave us an idea for the depth and challenge the university is facing in reaching their target. It created an opportunity to observe how different people left the rooms at the end of each day, as the last person in the room would be different daily. It also examined the extent that energy was being wasted on campus and helped determine if there were any measures in place to prevent this, like energy control measures and signage to help address the issue. On the last day we compiled our results, which will be discussed in the next section. To analyse our results, we compiled the data into the following spreadsheet to summarise and make it more concise for interpretation. We included the opposite of each heading to ensure better comparison and analysing in the discussion section. To get the results seen in Table 1, we added the sections from all 8 buildings together for each day. For example, Day 1, we added all the empty rooms that were surveyed across the 8 buildings in order to get the total number of rooms that were surveyed on the day. We repeated this process for the other sections of each day, and at the end we came up with a total number of rooms that were surveyed during our 4 days of investigation. We then divided each section by the total number of empty rooms that were surveyed during the period to get the percentage of this section for the period. After analysing our results, it is concluded that unnecessary use of energy in the areas covered is not as high as expected. A total of 269 rooms were sampled across the buildings. That result seen in Figure 1 shows that 47% of the rooms had their lights on when the building was not in use. Although this is not as high as expected, but it still indicates the presence of hotspots in some buildings. As seen in Figure 3 and 4, the results show that only 13% of the buildings had light detectors present and 17% had switch off prompt stickers and energy saving signs respectively. Looking at the individual results of the buildings, it's easy to identify hotspots. These are areas with unnecessarily high energy uses based on the data that was gathered. The new buildings tend to have less hotspots compared to older buildings. These buildings have always had the lights and heating off whenever the rooms were empty. However, in Baines Wing, Parkinson's and Roger Stevens, a significant amounts of lights when heating were just left on when empty. We recommend energy control message and behaviour change signage need to be implemented across the campus. More motion detection lights would also improve energy savings. Out of the 269 rooms, only 36 of them had motion detector lights. Having these lights prevents leaving lights on by mistake. Another benefit is reliability, because it also uses body heat as well as movement, which can be adjusted to ensure the motion switch turns on and off at the right time. We noticed that most rooms and lights left on, the switch were quite hard to operate. This can be discouraging for people trying to turn the lights off. However, motion sensors lights have no switch getting rid of this problem. In terms of energy saving signage, more needs to be created, preferably using recyclable materials. We noticed the rooms with signs were quite small and not very informative enough. It would be better to make the signs bigger, more visible and more informative. Also, for the university to be more sustainable and reach their set target to reduce carbon emissions, they could implement sustainable energy buildings that are both environmentally friendly and economically feasible. In addition to traditional energy saving, there is a need to introduce environmentally friendly energy technologies to achieve further significant reductions. Methods that can be applied are based on standard energy conservation methods mixed with innovative technologies which include using renewable energy. Research shows that energy efficiency in buildings is the first and fundamental step towards achieving sustainable energy buildings. Energy efficiency measures can be developed for old buildings that need refurbishing and for new buildings just before they are constructed. Thermal modernisation for old and poor insulated buildings is carried out to achieve sustainable reductions in energy consumption and to improve indoor climate conditions. The energy efficient activities during refurbishment are focused on reducing energy demand in buildings, which is mostly achieved by improving the building envelopes, replacing heat sources and reducing heat losses in distribution systems. New buildings could also be designed with the idea of zero energy buildings in mind. The concept is now seen as a realistic solution to help reduce the use of energy while reducing CO2 emissions. The building usually has zero net energy consumption, meaning the total amount of energy used by the building is about equal to the amount of renewable energy that is created on site, resulting in lower energy consumption and greenhouse gas emissions. Further analysis should be done on the methods to ensure sustainability and feasibility for the university. There were several limitations in this investigation. The results do not completely support the claim made by the university that the challenges faced in reaching their target due to lighting and heating systems being left on when not in use. The results show that 53% of lights were turned off and that 75% of heating systems were turned off. This might be due to the sample size being small and does not fully represent the campus. We wanted to survey the buildings after lectures, but there was only a small window of time to do so before the buildings or doors got locked. Whoever locks the buildings might have switched off heating and lights, affecting results on how much energy was actually wasted. The audit was too short to get a good idea of energy wasted, and the season and weather may have affected the results too. As one would expect during winter, the heat might be left on and in summer the aircon might be left on. In future, carrying this audit out during different seasons and for longer time periods would improve the validity of the investigation and give a better idea of how much energy was being wasted over the year. The sample size should also be bigger. If possible, all buildings on campus should be audited and hotspots to ensure effective measures are put in place everywhere. In terms of the building getting locked early, preventing research, the key to the building could have been given to the group in charge so a proper audit could have been conducted thoroughly through the evening. Finally, once the measures suggested have been put in place, another audit could have been carried out to see if the measures are successful. If they have helped, it would then be worth auditing more buildings on and off campus, then employing the same measures to further reduce energy uses across the entire university.